Okay, this Chapter 7 performance task is a little bit of an open-ended thing. So, again, we're looking for reasoning, explanation, as well as accuracy. So, the instructions say the way an equation or expression is written can help you interpret and solve problems. Of the four choices, which representation would you rather have when trying to solve for specific information and why? Again, I'm looking for you to explain why. For each setting, there's a set of expressions that you might use in each situation. Select the expression that will best help you answer the question. Finish the problem, solve the problem, and explain why the selection you made was the best choice. So question 1 looks at find the height of a parabolic balloon arch. So remember the shape of an equation is a parabola. So we want to find the height of this arch at its maximum value. We know that the x-coordinates are at 3 and 7, given that that's the feet in between. So we know that there's 4 feet in between. Remember that the line of symmetry of a parabola is going to be a midpoint of those two bases. So we can find that as the x value of our parabola and then substitute in to find our y value. Note that each of these equations will give you the same response, but which one would you choose to use to solve this? In question 2, we want to find the total footage of a fence that surrounds a rectangular area that is 2x plus 3 wide and 3x plus minus 5 long. And we want to find that perimeter when x is equal to 6. Now in this set of problems, there's an outlier in that some of the problems won't give you the same answer. Think about the how you find perimeter. It's going to be adding up the sides. So look and find the equation or equations that best shows you adding up the two widths and the two lengths, and then solve that when x is 6. The next equation talks about a tennis ball thrown straight down from the top of a building with an initial velocity of 30 feet per second squared. The time in seconds after you throw the ball is represented by t. We want to find the height of the building. In this one, all three answers will give you the same, but you want to go back and look at the course materials to see in the equation ax squared, or the standard equation bx plus c, what a, b, and c each represent. The key thing here is that one of those will answer the question that you're looking for. The next one, again, this time we're looking for volume of an aquarium. So we're looking for volume, which is a three-dimensional. So you're going to have some sort of a base, which is going to be length times width, and you're going to have some sort of a height. You need to look at the formulas to see which one gives you length times width times height, when the value of the width is 32 centimeters, so you're going to use 32 for your x value in that. And again, some of them will give you the same values, but one will be a lot easier to calculate. Number 5, we're looking at area. So just like in number 2, where we're looking for perimeter, Remember, area of a rectangle is going to be length times width. So again, you need to find the formula or the equation that's going to give you 3x plus 5 times 4x minus 1 when x is 35. Oh, actually you need to do this. You need to find the x value when 3x plus 5 is equal to 35. So do that first and then go ahead and find the area using the x value that you find. Last problem, number 6. We want to find the area of a rectangular swimming pool when we change. So the original length is decreased by x meters and the original width is increased by x meters, and we use x of 3. Again, find an area formula that represents that. Substitute 3 for the x and go ahead and calculate that. You will not need to do number 7. Now again, remember in problems 1 through 6 that you need to explain your reasoning. You need to identify which of the 4 formulas you chose to use, explain why, and actually find the value of what's being asked for.